In this video, we're going to graph and write inequalities. An inequality is a mathematical sentence that uses the symbols greater than or equal to, or greater than or equal to compare two amounts. The solution of an inequality is the set of values that makes the inequality true, which means the solution of an inequality can have more than one answer. Okay, these are the four inequality symbols, and students often have a hard time remembering which symbol means less than and which one means greater than. So I tell them to read it as a sentence. When you read sentences or a paragraph, you read from left to right. So we're going to read the mathematical sentence the same way. We're going to read from left to right. And when we do that, looking at the first one, if I'm reading left to right, the first part of the symbol I encounter is the small part. The small part means less than. If I'm reading from left to right and I encounter the large part first, that means greater than. So when we're dealing with inequalities, it's best to try to read from left to right to understand what the solution set is. Now, the symbols, less than or greater than, are represented on the graph as an open circle. And that's because the solution set does not include the number that the graph starts on. Conversely, the less than or equal to or greater than or equal to symbol is a closed circle because the number that the graph starts on is included in the solution set. Okay, my first example is x is less than 2. And in words, what that means is all real numbers that are less than 2. Understanding an inequality, if my real numbers or my solutions are less than 2, that means 2 is a maximum number and all my answers need to be less than that. So I'm using a less than symbol. I'm going to draw a open circle at 2. And because my solutions are less than 2, all of my solutions need to be to the left, or less than 2. So 2 is a maximum, and all the solutions need to be less than 2. The solutions do not include the number 2. In this example, I have x is greater than -4, which also means the solution is all real numbers greater than -4. So my solutions need to be greater than -4, which means -4 is a minimum amount. Because it is a greater than symbol, I'm going to have an open circle at -4, and my solutions need to be greater than -4, so they're going to go to the right, starting at -4 and going to the right, but not including -4. In this example, I have x is less than or equal to -5, which means all real numbers less than or equal to -5. That would mean that all real numbers, my solutions, need to be less than or equal to -5, which means that -5 is a maximum number. And because it is a less than or equal to symbol at -5, I'm going to have a closed circle, so we're going to fill that in. And my solutions need to be less than or equal to -5, which means they need to go to the left. In this example, you'll notice right away that it's written differently than the previous three. in that the number is now on the left and the variable is on the right, but just read it the way it's written and translate it into an inequality. It says 6 is greater than or equal to all your solutions. So if 6 is greater than or equal to all your solutions, that must mean that 6 is a maximum amount. And because we are using a greater than or equal to symbol, that means at 6, I'm going to have a closed circle. And because it is greater than all the solutions, that means that all the solutions actually lie to the left. Now it's time to write inequalities. And we're going to start with my solutions, which are x, and the point at which the graph starts at, which is 8. And I need to decide which symbol goes in between the x and the 8. So this is an open circle, which means it's either going to be a greater than or less than symbol. Because 8 is a minimum and all the solutions are going to the right, that means that my solutions are greater than 8. In the next example, I have 7 and an open circle, and my solutions lie to the left, which means 7 must be a maximum number, and my solutions are less than my 7, but do not include the 7 because it's an open circle. The last example on this page, my circle is closed at 4 and my solutions lie to the left, which means that 4 is a maximum number, so my solutions need to be less than that maximum of 4, or equal to, because it is a closed circle. Okay, let's look at just a few more examples. In the first one, I have -3 with a closed circle, and my solutions are lying to the right. This means that -3 is a minimum, and my solutions are greater than or equal to -3 because -3 is a minimum. In the next example, my graph starts at -5 and it's an open circle, and my solutions lie to the left, which means that that -5 is a maximum number, so my solutions are less than -5. And finally, in my last example, the graph starts at 6 and it's a closed circle, and the solutions lie to the left. So that means that 6 is a maximum number, and my solutions are less than or equal to that 6. And I'm going to write this last one a different way. I could say that 6 is greater than or equal to all my solutions. And if you notice, this inequality is the exact opposite of that one. I've just flipped things around. The number came first, whereas it was second here, and the variable is on the opposite side, and the symbols are also opposite. They actually, when graphed, come out the same exact thing. It's just some people see inequalities this way better, and there are some people that see them this way. Both of them are correct. They both graph the same solution set right there. That's the end of our video on writing and graphing inequalities.